So hello again, this is section 3.7, limiting reactants in your book. This is problem 3.77. Let's work on part A, which is the limiting reactant when 1.85 moles of sodium hydroxide and 1.00 mole of carbon dioxide are allowed to react. As you see on here, I just calculated the moles of the product, assuming that we have sodium hydroxide as a limiting reactant, and in this case, the second case, this is what we got whenever we assume that carbon dioxide is a limiting reactant. So in order to solve for the limiting reactant, you can either choose between the first scenario, when we assume that sodium hydroxide is a limiting reactant, or solve for the case when you assume that carbon dioxide is a limiting reactant. You should get this answer or this answer. So since the amount of the product that we got, assuming that the sodium hydroxide is less than the amount of the product that we got for the second case, assuming that the carbon dioxide is the limiting reactant, sodium hydroxide is the limiting reactant. Why again? Because the amount that we got on here is less than the amount that we got on the second case. So let's work on the second part. How many moles of sodium 2CO3 can be produced? So basically you have to do what we did on the first case, 1.85 moles of NaOH and 1 mole of Na2CO3 over 2 moles of sodium hydroxide. Cancel these units out and we get that this is equal to 1.925 moles of sodium 2CO3. As you see, we just write it down whatever we put on top, why? Because remember that all those reactions are based on the limiting reactant. So the amount of the products that we're going to get at the end of the reaction depends on the limiting reactant. That's why we have to do the same for the second part. And then how many moles of the excess reactant remain after the completion of the reaction is done. So as we know, in this case the excess reactant is going to be the carbon dioxide. So we have to use the 1.85 moles of sodium hydroxide in order to get the moles of carbon dioxide. So 1 mole of CO2 over 2 moles of sodium hydroxide. This is equal to 0.925 moles of carbon dioxide. So now we just need to subtract the 1 mole of carbon hydroxide that we had at the beginning minus the 0.925 moles of carbon dioxide that we got after the reaction got to completion, and this is equal to 0.0073 moles of CO2. So this is the amount of moles of the excess reactant that remains after the reaction is done. So let's work in a second example. This is 3.79 in your book. So part A says, which is the limiting reactant? Again, we have to choose between two scenarios. Either the sodium bicarbonate is the limiting reactant or the citric acid is the limiting reactant. So let's work on the first scenario. 1 gram So 1 gram of sodium bicarbonate following the equation, we know that 1 mole of sodium bicarbonate is equal to 84.0 grams of sodium bicarbonate. Remember that that's from the molecular weight. So per 3 moles of sodium bicarbonate, we have also 3 moles of carbon dioxide. Per 1 mole of carbon dioxide, we have 44 grams of carbon dioxide. We cancel these units out and we get that this is equal to 0.524 grams of carbon dioxide. Okay, now let's do the second scenario. Assuming that the citric acid is the limiting reactant in this case. So 1 gram of the citric acid we have 1 mole of the citric acid over, this is equal to 192 grams of the H3C6H5O7. So now, following the equation that we have on top, for each mole of the citric acid, there is 3 moles of carbon dioxide. For each mole of carbon dioxide, we have 44 grams of carbon dioxide. Which is equal to 0.688 grams of carbon dioxide. So again, as we did it before, since in the first scenario we got a lowest amount of lower amount of CO2, the sodium bicarbonate is the limiting reactant. Is the limiting reactant. Why? Because 0.524 is minus than 0.688, and this value right here we got it whenever we assume that sodium bicarbonate was the limiting reactant. So now let's solve part B. Part B is the same as before. Since this reaction is carried out by the limiting reactant, the answer for part B is the same as we got on the first case. .524 grams of CO2. So now let's solve the last part. The last part says how many grams of the excess reactant remain after the limiting reactant is completely consumed. So let's work on the last part. Sorry guys, I'm having trouble with my screen right now. I don't know why. Okay, so the last part, we need to solve for the amount of the citric acid based on the amount of the limiting reactant that we got at the beginning. So 1 gram of sodium HCO3, so 1 mole of NaHCO3, we have 84.0 grams of NaHCO3 per 3 moles of NaHCO3, we have 1 mole of H3 C6H5O7. We cancel these units out. And now remember that we want to get the grams of citric acid, not the moles. So we need to do this last conversion in here. 1 mole of CH3 C6H5O7. This is equal to 192 grams of citric acid. This is finally equal to 0.7619 grams of citric acid. So we subtract what we had in the beginning for the citric acid before going far with the reaction. So we have 1 gram minus whatever we got after the reaction was done. So 1 gram minus 0.7619 grams of citric acid. So this is equal to 0.2281 grams of CH3 C6H5O7. This is the answer for part C. The grams of citric acid that we got after the reaction was completed.